Right, the 2014 sample question, it was about equation to words and tied in with area. A rectangular site with one side facing a road is to be fenced off. The side facing the road, which does not require fencing, is L meters in length. The side perpendicular to the road, the sides perpendicular to the road are X meters in length. The length of fencing to be used to enclose the rest of the site is 140. Write an expression in terms of X for the length of the side facing the road. Okay, so a couple of things. If you have the benefit of farming and understand fencing, you'll know that they mean that just the three sides here are going to be fenced off, okay? Because they say the side facing the road does not require fencing, okay? So we know that that fencing is 140 meters long. Okay, I just marked an X in at the top, the X and the top and the bottom is X. If the side at the road is L, well then that one has to be L as well, okay? Because it's a rectangle and opposite sides of a rectangle are equal in length. Right, the other thing to note is you have to write an expression for the length L, okay? So what does that mean? Well, that means that essentially I want to write L equals. Okay, that's what I want my expression to look like. Okay, so that's where I'm going with this question. He's X, he's L. Okay, so to do fencing, you need the outside, you need to know how long is the outside of that site, or you need the perimeter of that site. Now, typically for a perimeter of a rectangle, we would add up all four sides, okay? For this particular one, it's only three sides that's been fenced. So those three sides, X plus X, well, we'll go X plus L plus X, I'll get it right yet, plus X is being fenced and the length of fencing to be used is 140. So all I did was start in one corner and walk around it. That was my first X. Then it was a length L. Then it was a length X and it's equal to 140. So let's tidy up. I have 2X plus L being equal to 140 and I have to write it in terms of the length. So they want the length equals. Okay, so to do that, I have to look at what else is on the same side as the L. Well, it's 2X, so bring him over the other side or subtract 2X from both sides and you'll get 140 minus 2X. Okay, so that is an expression for the length of the side L in terms of X. Okay, so the perimeter or the fence is 2X plus L equal to 140. In terms of L, it's 140 minus 2X. Okay, so they are the same equation, they're just written in different ways. Okay, the next part said, show that the area of the site in meters squared is minus 2x squared plus 140x, okay? So if you look at that, you might go, my goodness, I don't see where that comes from. But if you use your knowledge of area, then area of rectangle, you know, is length by width. Okay, so for this particular side, it doesn't matter which letter is which, we leave L as L, so it's L times X. Okay, so that's my area. Okay, so if I had numbers, I would put them in and multiply them by each other. I don't have numbers, I just have algebraic letters that are standing in for numbers at the minute. Okay, so now I go, right, I know that's my area. This is the answer they want. So what are the differences? Okay, well, the first thing I see is that there's no L in my answer up here. Okay, so what could I sub in for L? And I see that there's a load of X's. Okay, so what you do is instead of L, you sub in this. Okay, because that L is also equal to 140 minus 2x. So I could go 140 minus 2x instead of L, and then leave the x where it was. Okay, and then I need to multiply it in because again there's no brackets up here. I'm basically working with this to make it look like this. So 140 by x is 140x, and then minus 2x by that x on the outside is minus 2x squared. Okay, so again, I'm looking up the top and I'm seeing, right, what's the differences? Well, they look similar now. I just have them backwards in the bottom. So it is an easy job to swap them around. Okay, and that's how you work those ones. Okay, more to this question. Let f be the function, f of x maps onto minus 2x squared plus 140x. Evaluate f of x when x is 0, 10, 20, 30, 40, 50, 60, 70. Hence, draw the graph of f for 0 is less than or equal to x is less than or equal to 70. Okay, so rolled a bit of functions in here. Okay, so this is a sample question, and sample questions can be harder. Okay, so let's draw some sort of a table so that we can work out all of these values. So I have 0, 10, 20, 30, 40, 50, 60, 70. Okay. So excuse my digital drawing. If I had a ruler, it would be great. Okay, but anyway, something like that, you get the gist. So these are my x values, and these are my f of x values. So 0, 10, 20, 30, 40, 50, 60, 70. Okay, and then this is my function, which is going to give me my answers. Okay, of course you could do your table like this, which is probably the more natural way to do it. Okay, that would be perfectly fine too. I just didn't think of this particular way at the start. Okay, I thought of this type of a table. Okay, but this is probably the more natural way of doing it down here. And then you get your y functions. So that's typically how we do it for functions. For some reason, my brain didn't think of it that way this time. I have no idea why. Okay, so let's continue with the table I have up here. So you can do it manually. So when I say manually, I mean minus 2x squared plus 140x. That's what f of x is equal to. Okay, when x is equal to 0, we're replacing all of the x's with 0. Okay, so that I get minus 2, 0 squared plus 140, 0. So I'm going to get 0. F of 10 will be equal to minus 2 times 10 squared plus 140 times 10. And you put that into your calculator. Squared plus 140 times 10. Okay, and I got 1200 for him. Okay, and f of 20, and you work all the way down. Okay, so that's how you manually do it. Okay, or you can put it into your calculator. So what I normally do is I do one manually to show the examiner I know what I'm doing when it's manual, and then I will go for the calculator, okay, because it's faster and because they nearly expect you to do it. So you're going to mode setup. Okay, and regardless of whether you have the ClassWiz calculator, which is the main one that's out there now, you're going to option 3, which is a table. Okay, and you should get f of x equals to and a flashing bar. Okay, so you hit your minus button. Okay, you hit your 2, and then you want to put in x. So to get at the x in the calculator, you need to put in alpha and the bracket. Okay, alpha is up on the top left, so hit alpha and hit the close bracket, and you should then get a big X like that. Okay, and then you hit squared. You see the X squared button, it's just under it's at the top under the circle, and then you'll get your little squared up there. Okay, and then you hit plus 140 just as you would normally, and then again you're doing alpha X again. Okay, so anytime you need to put an X into the calculator, it's that alpha, close the bracket, okay? And even if this letter was t squared, for example, okay, to put that into your calculator, you only have one option. Your calculator will call it an X. It doesn't matter for the function of your maths. Your calculator doesn't know that the question had t's in it. It treats the letter the same way, and the answers will be the same. Okay, and then you hit equals, and you get start question mark. Well, we'd like to start our x values at 0, so I'm going to hit equals, and then when you hit 0, it logs it into the memory of the calculator. You then get end question mark. We would like to end at 70, and you hit equals. Okay, and we're going up in what step size? Well, we're not going to go up in ones here. We're going to go up in step sizes of 10. So hit 10 and equals. Okay, and what you'll do is you'll get a column down the very left, which is just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's just row 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then you should get your x values down the next column, 0, 10, 20. And if you hit the circle in the middle, hit the down arrow, you'll get the rest of them. And then over in the far right, you'll get your f of x values, or what we call our y values. Okay, so I can see there that I have 0, I have 1, 2, 0, 0, then I have 2000, then I have 2400, then I have 2400 again, then I have 2000, then I have 1200, and then I have 0 again. Okay, so I hope everybody gets that. So whether I draw the table down or across, I will show, so even if I do it like this, I will show my 0, 1 here, and I will put all of my answers down here. Okay, there's your x, there's your f of x or your y, whichever way you want to call it. Okay, and that's how I will give my answer to the examiner. So I don't bother writing all of these in. The examiner knows exactly where I'm getting at. It's the calculator. That's what they expect. That's why it's in the calculator and you're allowed to use it. Okay. Right. So that's our thing. Next, we had to draw a graph. Okay. Now, my graph is not going to be great on screen, but let's attempt. Okay, so some of the things you have to be careful of graphs. This is 0 here. Okay, that's always 0. The number of boxes between each of the numbers have to be the same. So I'm going up in 2 boxes. I actually could have probably gone up in 3 boxes. Okay, and then I don't need to do minus because I have no minus values on my x. I also don't need to do minus values on my y. So that's why I just did, I suppose, a 2-sided graph, if that makes sense. Okay, so always look at your numbers and figure out then what graph makes sense to draw. So I need to go from 0 to 2400 here. Okay, so I'm going to have fairly large step sizes. 300ths would be nice because it divides into most of them. 3, 6, 9, 12, 15, 18, 21, 24. Yeah, let's go up in 300ths. And again, it doesn't matter. You're looking at your page and you're seeing what fits for your graph. Okay, I could have gone up in 400ths. In fact, that would make more sense, actually, because it divides into all of them. So let's go up in 400ths. 8, 12, 16, 20, 24, and I can put in 28 if I want, but I'm not going to end up going that high. So that's my graph. Okay. Now let's put in the points. So these are what we call our couples. So x comma y. So my first point is 0, 0, which is here. My next couple is 10, 1200, x, y, always when we're plotting. So 10, so it's like a location on a map, and I go up to 1200, which is here. Okay, so that's my next point. My next point then, my next couple is 20, 2000, x, y. So 20 up to 2000 is here. 30, 2400, x, y. 30 up to 2400 is there. 40 is also 2400. 50, I'm coming back down again, is 2000. 60 is 1200, and 70, I'm back down. Okay, and then you freehand draw this. This is an inverse quadratic, so you want a nice smooth curve. And you never go beyond 0 and 70 like that. You'd never extend it because of this. This tells you the domain, which is the inputs or the x values that you want to draw your graph over. And x can only go between 0 and 70. So if you extended it, can you see you're plotting for these x values here, okay? So these are like the gates or the barriers that you don't go beyond, and you draw your graph in between, okay? And it's good practice to label your graph. And the name of this graph, the name of this function is f of x. Okay, and you can leave it like that, or you can do this. It depends what's your preference. Okay, so that's that graph and some sort of a table of data to represent it. And then I've seen questions where this is 10 marks. I've also seen questions where this is 15 marks. So well worth the effort of knowing how to draw a graph. Okay, now the next part of the question wants to know, can you read your own graph? Okay, so use your graph from part 3 to estimate the maximum possible area of the site. Well, this function, if we go back to the question, was the area of the site. Okay, so when I plugged my x values into this, I got area. So that meant that was area. And then what was my x values? Well, my x values was, we said the width, okay, or something like that. Or the length, that would have been perfectly fine to put down as well. It's one of the sides of the rectangle. Okay, so maximum possible area. So on your graph, and it's really important that you show the construction lines, okay? So we're going to dot across here. Now, one thing to note, if you have 2 points on a graph that are the exact same at the top, so you see the way we have 2400 and 2400 here and here. Well, a quadratic is round, so that means that graph had to go up a bit to come down a bit to be on the 2400s, okay? So the maximum area of that graph is a little bit above 2400, okay? So maybe we would say 2450, okay, as the maximum area, okay? And this word estimate, you're reading it off your graph, okay? So that's why the more you can spread out your values. So in other words, if I had a really high graph here, I might only be going up in 200s, for example, and then my graph would be more accurate. I'm not, I'm going up in 400s because I was restricted by space. Excuse me. So my graph, when I read off it, will be less accurate than somebody else's. But that's fine. That's the area, and it's units squared because it's area. So I reckon the maximum possible area of that rectangle is 2450 units squared. And then the graph said, what was the area of the site when the road frontage was 30? Okay, so I'm going to swap color again. Let's go for a green. And I dot up from 30, right up. And whenever I touch my curve, I come across to the y-axis. Okay, you can also see it here. But you need to have the construction marks on your graph. That's where the marks are for this question. So 2400 units squared would be the answer for that particular one when the road frontage or the length was 30 meters long. Okay, and of course you could call him L now if you wanted. Okay, and that was that 2014 sample question.